All right, we're good to go. Thanks everyone for joining my talk. Help, I've created a serverless monolith. And even though this monolith looks a bit sad, I promise you no monoliths have been heard when I was preparing this presentation. You just have to take my word for it. So my name is Marc Duiker. I'm a senior developer advocate for Ably, where we enable developers to build live and collaborative experiences based on WebSocket technology. I've been a Microsoft MVP in the Azure area for the last 4 years, and yeah, my primary focus has always been serverless and Azure functions and durable functions. I'm a big fan of pixel art, mainly creating pixel art. So the picture on the left here is the Ably DevRel team, and you can probably make out which one is me. But you may have seen some of my pixel art work in some other places. Who is using VS Code as their code editor ID here? VS Code user? Oh, quite a lot. Okay. So who has installed the most brilliant extension of them all? VS Code Pets. Yeah, now I see only one. So yeah, there's okay. So people, this is VS Code Pets. It's a very tiny extension for VS Code. It does absolutely nothing. You can just load some pets in there. There are about, I think, 10 different pets you can choose from. They just run around a bit. You can throw a ball and they fetch the ball. That's it. It's completely pointless, but it's fun. So I've created more than half of these animals there. So please go install that. This is the first shameless self-promotion. There'll be 2 more in this talk, and I'm not sorry for it. All right, so let's get down to business. Serverless monoliths. I'll ask you some more questions later on, but I will talk about how agility is impacted when you have a badly designed serverless application, how complexity is involved, and how you can remove or move some complexity in your function app. And I'll give you 3 different strategies if you've decided that you have a serverless monolith and you want to break it up. So first things first, serverless monolith. So how many of you are developing serverless applications using function apps on Azure? Okay, quite some people. Okay, so you're in the right session. That's good. Perfect. So, and how many of you think you are currently having a serverless monolith? Some doubts, some need maybe. Okay, maybe I can help you realize some things today. Perfect. All right. So when you create serverless apps on Azure, I think it's easy, and I don't use the word easy that much, because when it's easy for me, it might not be for you, and the other way around. But I really think once you can either create it in the portal itself, so you immediately have a function app, or you create it in whatever IDE you want. But as soon as you have deployed a function app, because that's the unit of deployment in Azure, once you have that and you have one function, it's very easy to keep adding functions to it. And it's probably a bit too easy to do that, right? There's also, as far as I know, no limit on how many functions you can add to a function app. So yeah, it's both a blessing and a curse, I think. So it's very likely that over time, as you keep adding stuff to it, your responsibility of that function app will grow and will grow. And yeah, maybe after a couple of months or after a year, you think, did I just create a serverless monolith now? Maybe. Let's first do some definitions. So I'm also always quoting Wikipedia. In software engineering, a monolithic application describes a software application that is designed without modularity. So I think the main key is here that it's designed, so it's intentional, without modularity. So let's also look at the definition of modularity. Modularity is a degree to which a system's components may be separated and recombined, often with the benefit of flexibility and variety in use. All right, but I think that's pretty clear. So now let's have a look at traditional architectures, right? We used to have these very big, chunky application servers that contain our presentation logic and our business logic and our data access logic. And that application server, that was not modular, that was not flexible at all, right? So that was a monolith, because it was also designed like a monolith, right? So its intended use was just to be that, one complete, big, bulky thing. But these days, we have a completely different architecture, right? It's much more modular on its own, right? We have separate function apps, probably some queues here and there, more function apps, some storage. And of course, this single sequence of apps and queues and storage is not a complete replacement of your entire application server you had traditionally. Probably you have this, right? You have many more apps, dozens of them, all interconnected in some way, many different types of storage. Now, if you just look at one function app, so does does this function app, does it need to be designed with modularity, with flexibility in mind? Just the content of the single function app? I don't think so, because the whole flexibility, modularity in this system is in the architecture, right? It's having multiple function apps and decoupling with queues and multiple types of storage fit for a certain purpose. So the function app itself, it doesn't need to be modular, right? So I think actually every function app should be a monolith, right? It should be designed with only one purpose in mind. It should do one thing, and it should do it well. All right. So who here now comes to realization that they are having monolithic function apps? Yeah, a few more. All right. So a monolith is definitely not equal to bad, right? It should be a conscious decision, right? It's a design decision. What you should worry about, though, is does your serverless monolith slow you down? So let's talk about agility. Oh, by the way, I have a lot of these drawings of happy and sad monoliths, but I still need a name for them. So if you have a good suggestion for a name of this monolith, please tweet it at me or something, so I'd like to know. Quote from Martin Fowler: "We eventually agreed on agile as we felt that captured the adaptiveness and response to change, which we felt was so important to our approach." Well, these days every organization is an agile organization, right? We are all working sprints, and if a business decides to go in a different direction, one sprint later we could theoretically go in that direction. But does your technical stack, does it allow you to be agile as well, right? That's a bit of the question here. So in your sprint, you do a lot of different things, right? So you create code to add new features, you document it, you test it, you fix it, and you deploy it. And when you're just starting out on a new project, a new greenfield project, all these tasks take a certain amount of time. But let's say a half year or a year in, I'm pretty sure that it will take more time to do all these things. And again, that's because of the responsibility is growing, right? You're adding more lines of code to your application, things become more complex, it becomes more complex to test. This is not specific for serverless, it's related to all kinds of software development, but it also applies to your function apps. So it's very likely that your agility drops a bit over time because your application is growing. Of course, that's not what we want, but we need to be aware of this drop in agility. So how do we then measure agility? Well, I'm not sure how many agile coaches are here, but they probably want to throw around with story points and burn down charts and stuff like that, which I'm not a very big fan of, to be honest. I'll offer some alternatives to decide how agile you can be, and you can decide for your own if you're happy with those KPIs and metrics. One of these alternatives is called lead time. So then you'd look at the difference when a task appears on the backlog and when the work is completed, meaning it running in production. But the downside of this is, of course, priorities change, right? So a task could be on a backlog for weeks or months. So you're mainly looking at process and stuff like that. So not really is your function app maybe having some difficulty of technical complexity. So another alternative would be to look at cycle time. So that's the difference between the work actually started and when the work is completed. The only downside here is, you usually start your work early on in the sprint and you develop probably in the last day of the sprint. So it's very likely that your cycle time is equal to your sprint duration. So it's also not really relevant to monitor that because I'm pretty sure that stays constant. So monitoring cycle time as an indication for agility only works when you deploy immediately after you've completed your work. I think a good indicator for agility could be this, mean time to recover, or MTTR. It's a well-known KPI from incident management. And well, what does it actually mean? If you look at your downtime or your degraded performance and you divide it over the number of incidents you had in a certain time window, that's your MTTR. So as an example, let's say within a month we have 12 hours of downtime caused by 6 individual incidents. Our MTTR is 2 hours. Now just having this number doesn't mean a lot, right? It depends per organization. I mean, 2 hours of downtime for a financial organization, they might lose a lot of money, so it's a big deal, but for another organization, it's not such a big deal to have this 2 hours. What is important is if you keep an eye on this, right? So every sprint or every month, make sure you calculate this MTTR and see if it goes up or down. And if it goes up, then it means something is going on. So when you are tackling an issue, you have an issue in production, there are globally these 4 phases you need to go through. And you need to make sure that all of these phases are going smoothly, because that will lower your MTTR. So this has nothing really yet to do with how well your technology stack is, maybe just a bit. But you have to make sure that each of these 4 phases is really a smooth and quick experience. So it means finding the root cause, changing the code, testing code, and deploying the fix. So I'm going to give you a couple of tips how you can make sure that this MTTR cycle, how it can be a smooth experience. So first, finding the root cause. Right. Well, you need to be in the know, of course, of what's going on. So, of course, maybe a client can complain that something is not working, but ideally you have some logging in place that will alert you of what's going on. By default, Azure Functions already has some default logging behavior and stuff like that, but it's very likely that you want to customize and tweak that a bit, right? So don't just go with the defaults. I've put in a link here in this slide, and by the way, I'm using a lot of links in these slides, and I will make them available after the session. The hosted.json file, you can override dozens and dozens of settings related to logging and application insights. So when you are about to go to production with your function app, please make sure you tweak some of these settings, because you can change a lot of things related to sampling or excluding certain types or including certain types. So please make sure you cover this. Another thing that's related and also important is please also capture business events. So don't only monitor the technical things that go on in your application, but also capture business events. And I'll come back to this later. But it really helps with the communication as well, right? So if the customer is complaining about that something doesn't work for them, hopefully you've also seen it in your own logs, and you can use it to correlate the technical issues with the business events that are going on. Finally, don't just do capturing of events and do logging, but also make them actionable. So in case of Azure, it means you can use Azure alerts. You can choose dozens of different signals and define thresholds or have dynamic thresholds and make actions on them, like sending an email or posting it to a webhook. So make sure you have actionable logs so you can be in the know, even maybe before a client knows what's going on. The other 2 phases, I put them on one slide because they are really, ideally you want to be very quick in having access to the code, changing the code, and testing the change, right? So this cycle is called the inner development loop, and it's really important that this is a good, smooth experience. Yeah, that's also in your day-to-day work, but especially when there's a high priority issue going on and you need to fix something. Luckily, I think tooling-wise, we have come quite far with this already, because there are things like dev containers and GitHub code spaces make it very easy to have this inner dev loop really smooth experience, right? You just have to invest some time in it and configure your dev container and all of the dependencies and maybe some setup scripts that as soon as you need to change a code, you can spin up that dev container and you can start to work and test immediately. Well, what can you do about deployment and having that a smooth experience? Well, just automate everything, right? So don't just have a pipeline to build and test and publish your code of your function app, but also make sure you spin up your infrastructure as well, right? There are lots of infrastructure as code solutions these days, so please make sure you do that, right? So either if it's ARM or Bicep or Azure Developer CLI, which is quite new, or use Terraform or Pulumi, it's countless these days. The last tip for deployment, it might seem very obvious, but please don't disrupt production when you deploy a new version, right? I mean, if production is already down, then this is of course not an issue. But if production is running happily, whenever you either change a configuration or you push your new code, your function app will restart, right? So it won't be available for like 20 or 30 seconds. So, and if you're working in a high volume environment where lots of requests come in, you might lose quite some money if your app is not available. So you can do 2 things. Either you can use your deployment slots that are available with function apps. So you can create a staging slot and push your new code there or your configuration there. And then Azure Functions will make sure it will warm up this new code on this new instance. And once this new instance is there, you can swap the slots. So that's a great way of not having any downtime. An alternative is to put your function app behind a queue. So for instance, we have a website, and whenever someone places an order, it places a message on the queue, and the function app is then triggered based on the queue. But now, when you want to deploy to your function app, it's not available, it will restart, but then the website is unaffected, right? There's only a bit of a delay in handling because queues will be added to the, messages will be added to the queue, but as soon as the function app is up and running again, the queue will be drained and you have business normal. So you just have a bit of a delay in processing. In general, queues are always the solution in these event-driven architectures. So I gave you some tips of how to measure agility and how you can make sure that all of these phases when you do some debugging are smooth, but it could still, of course, be that your MTTR is increasing, right? So, and that has to do with complexity. So let's have a look there. So there are two types of complexity. There's essential complexity, and that's caused by the nature of the business problem, and that can't be easily reduced. So you can think of the traveling salesman problem, right? You have to find the shortest path between several locations. Well, that's essential complexity. The other type is accidental complexity, and that's caused by the decisions we make, because we decide to use a certain language, a certain framework, certain packages, certain architecture, and this can be reduced because we can make different decisions. So let's have a look at this accidental complexity. So as an example, here's our function app, and we have decided that it became unmaintainable, it contains too many functions, and it becomes too hard to test. So we decided to actually separate all of these functionalities into four separate function apps. That can be a good decision, sure, but you have to make sure you actually make a clean cut, because you could end up with a distributed monolith. Well, what's that? It appears like a distributed system with 4 separate components, but something is not completely modular yet, right? There are still relations somewhere, and usually they are a bit hidden, so you're not really aware of this. An example could be, yes, we have decided to create separate function apps in Azure for it, but for every function app, you also need a storage account. But it could be that it was either forgotten or decided not to do, to also create separate storage accounts for these function apps. So we could still have one shared storage account for all of these function apps, which ideally you shouldn't do. Because you can imagine that maybe in 1 or 2 years or so, the responsibility of your teams is changing, and one of these function apps moves to another team, and that team then ends up with doing this maintenance over this function app, but yeah, they didn't realize that there was still a shared storage account, so yeah, there could be lots of issues with that. The same goes for shared configuration. That could also be a risk. So whenever you do decide to make a cut and take things apart, make sure you make a very deep cut and take everything apart, including the infrastructure and all of the configuration and stuff. So what I'm saying is, complexity does not simply evaporate. Complexity usually moves around. So in case of going from 1 function app to 4 function apps, sure, we have 4 smaller function apps with less code, and it's probably easier to maintain those individual function apps. But we are requiring now probably more Git repos, more CI/CD pipelines, more monitoring and logging, things like that. So we are moving complexity away from the code, but maybe more to operations. So there are different things of how you can actually move complexity out of your way. So I have one of the examples I just gave you, move code to another app, that's one. Another one could be using third-party packages. For instance, if you want to do validation of your business objects, well, there's this thing called Fluent Validation in .NET, which I really like. So I really hope you don't write your own validation logic for this. Another example could be like creating realistic test data. There's a Bocus for that. So please make sure before you write any code, look what's out there, right? Because you can save yourself quite some time. But again, about moving complexity does not go away completely, because now you are dependent, of course, on a third-party package, a third-party library. And you probably have to keep up to date with it, right? Because there might be security issues related to them and stuff like that. If you can take it even further, maybe you could look into even complete third-party services instead of packages itself, right? One instance or an example could be maybe you need to send updates from your backend to a front end, and you can do that based on WebSocket technology. Well, you could host your own WebSocket server and do everything yourself, but there are lots of services out there that can do it for you. For instance, SignalR and Azure Web Apps Up, but another could be Ably. Shameless self-promotion number 2. Just one left. Another example of how to move complexity out of your way, if you want to do function chaining, so we go from function A and then function B and then function C. Hopefully you're not doing this with HTTP calls, right? Because then function A needs to know about function B and B needs to know about C. So we don't want to have this coupling. Maybe you're thinking about this, you want to maybe use queues. So function A has an output binding to a queue and function B is then triggered on the same queue and so on. This is a perfect solution, very nice. But it does require you that you create the infrastructure for creating the queues and also making sure the configuration of the function apps is in order to look at those queues and stuff like that. So there is a thing that can help you, and that's called durable functions. So who's heard of durable functions? Quite some people already. That's very nice. Okay, maybe most of it is not new for you, but still. So with durable functions, you can create workflows or orchestrations in code. These workflow functions are stateful. It means they're actually persisted to storage. By default, it's in a storage account, but these days it can also be SQL or event hubs. There are more options these days. And because they are stateful, it allows you to do all kinds of interesting patterns, right? You can have really long-running functions, or they can be triggered, or you can use timers, and you can wait for events. It's really super powerful. So I'll give you a few examples what you can do with these durable functions. So this is an orchestration function, and it's identified by this orchestration trigger attribute, which allows you to have this context, and in this context you can make a call to an activity, and an activity call is usually that does the actual, let's say, call to a database or call to another endpoint and so on. So what we do here is we do a chaining of 3 functions, activity function A, B, and C, and we're doing that by this await context dot call activity async, and we expect then a type string back. We provide the name of the activity function, and we provide an input. In this case, we provide null as an input. And the orchestrator will now schedule this call to this activity function, but it will also wait until the result has come back. And so it won't continue. So once the result is back from activity function A, we can use that as an input for the next activity function, and so on. And finally, when the result of C is ready, the orchestrator is done. Another example of durable functions is you can do this fan-out, fan-in pattern, and that's really powerful because it's usually quite difficult to do. Let me go back first. So when you want, this is very useful if you want to do execute several functions that are not related to one another, and you want to execute them as much in parallel as possible. But then after they have been executed, you still want to wait and aggregate the results. So this is an example again of an orchestration function that does that. What I'm doing first is I create a list of task string, and string was the output type of the activity functions. And I am adding the tasks to call the activity functions, but we're not awaiting them here yet. So we are not scheduling and executing these activities here yet. We basically have the definition that we are going to execute them later. So I'm doing the same for function B and function C. So now I have 3 tasks in this task list. And at this moment, the await task when all. At this moment, we'll do the scheduling and execution of these activities. And the orchestration will then wait until all of these results have been returned. And we can return that from the orchestrator. It's a really powerful and useful thing. The third and final example is something that is a bit weird, and I'm not sure if I'm really happy with it, that you can do it, but you can use an orchestrator to do chaining of sub-orchestrators. So now it gets maybe a bit meta. So here's an example of an orchestrator that calls 3 different sub-orchestrators in a function chain. So it looks very much like the regular function chaining, but now the method is called call sub-orchestrator async. And although this is nice, and you can create really flexible and modular function apps with this, but just a couple of slides before, I said, well, I don't think it's up to the function app to be very flexible and modular, right? I think a function app should just do one thing and one thing very well. And I think when you go very deep, orchestrators calling other sub-orchestrators, which you can potentially call another sub-orchestrators. You can go many levels deep, and there's also no limit on how far you go with this. So it can be a bit tricky, I think. So in general, durable functions are great. I think it's the best thing out there for Azure Functions. So for the people who are not using it, definitely have a look at it. If you want to know more about some advanced use cases, I've put a link here to one of my GitHub repos that contains some very nice combinations of fan in, fan out, and waiting for events and using timers. But definitely don't overuse it, right? Because it's also very easy to start with an orchestrator and keep adding activity functions to it. But yeah, then you end up with calling like 50 different activities in one orchestrator, and that's also not a good sign. So it's great, but keep it small. Right, so now it's time for the bad news. So let's say you do think, okay, I have this monolithic application, but it's very hard to maintain. So yeah, we have to have the difficult conversation to break it up into smaller parts. So I'm going to go through 3 different approaches, how you can decide how you break up your function app. So the first one is based on bounded context, the second one based on resilience, and the third one on scalability. So who knows about, who heard about bounded context and domain-driven design? Okay, quite some people, perfect. So bounded context is a concept from domain-driven design. It's a really powerful way to design complex systems when the design is really central. And a bounded context is a partial implementation of a part of the domain. So within this bounded context, that could be a web application, or it could be a function app, it could also be multiple function apps. But in general, it's a implementation of a part of the domain. So as an example, I have the e-commerce domain, and a partial implementation of that domain could be the product catalog. And that could be a service that contains all of our descriptions of the products and the images and so on. And another implementation of a part of the domain is the pricing bounded context, right? That can also be a service, and we can call it to get the price based on the demand and availability. Another important thing with domain-driven design is ubiquitous language. So that identifies the terms and concepts within a bounded context that are unambiguous and agreed upon by all stakeholders. It's a bit of a long sentence, but it comes down to make sure you use proper naming for your events and your entities within your function app that are understood by everyone, right? So that makes it very easy then to communicate about with your business or with your end users. And it also means that if you do logging inside your function app as well, again, make sure you also capture these business-related events around these domain objects. So as an example, this is an account entity, but it can have a very different meaning depending on the bounded context. So if we are mentioning an account in a billing context, we probably then mean a bank account with a certain currency and a debit or credit and a bank account number and so on. But when we talk about account in a shopping basket, well, then it's probably more like a user profile information, right? With some logging information and some address information and so on. So in general, domain-driven design also gives some guidelines about teams and bounded context, and they say you should have one team work on one bounded context. A team can also work on multiple bounded contexts, but you should not have multiple teams work within one bounded context, right? So it's all about keeping it simple and to the point and having also effective communication and responsibility. So one team should be responsible for one bounded context. The same goes for Git repos, right? So if you look at one Git repo, it should only implement one bounded context. Again, it's about simplicity and making sure that all of you use ubiquitous language and that the intent of the code that you see is super clear for everyone. Well, how does this relate to our function apps then? It means that if you look at one function app, that should only implement one bounded context, right? It should not implement more bounded context. And by default then, it should also means that our function app uses ubiquitous language, right? So if your domain users look at the code, they should recognize all of the domain objects and events that are in there. All right, I'm asking you, the next time you look at your own function apps, if you didn't do any domain-driven design or whatever, take a close look at it, try to decide what kind of bounded context you have implemented, and maybe you can identify some parts, some functionalities that are actually not part of that bounded context, but actually belong in different bounded contexts, right? And then it's appropriate to move these things out. Okay. The second strategy is about resilience, and I'm throwing in another quote. Resilience is the ability to provide and maintain an acceptable level of service in the face of faults and challenges to normal operations. So it's important to realize an acceptable level of service, right? Because things are never 100% up all the time, and faults and stuff like that will always happen, right? Because cloud stuff breaks continuously. It's in the news every month or so. Somehow it always appears to be DNS. It is interesting. But I'm sure a lot of more is going on at these cloud service providers, and we don't even know of these things, right? I mean, things fail continuously, and the responsibility of how resilient your application is, there are different parties responsible for that. So I think at the lowest level, the cloud service provider should be responsible for that, right? So if a hard disk fails or if a machine fails, they should wheel in a new server rack and so on. So this is not up to you; they are responsible for it, which is good, right? But one level above that, then I think it's our responsibility, because we have to create a system architecture that's resilient, right? So it means we have to pick and choose the proper services that our cloud service provider supports. And instead of choosing a very big virtual machine and we host all of our services and database on it, we should probably pick and choose and have some static web apps and some function apps and some Cosmos DB and some table storage to make sure that if one part of the system fails, it doesn't bring down the rest of the system. At the top level, there's the application architecture, which should also be resilient. So if your application makes a call to a third-party API and we get back an HTTP 500, what does your application do? Does it completely crash, or do you simply log an exception and stop, or do you do a retry? And how often do you retry, and how long do you keep retrying? These are usually quite tricky things to think about, but it's important to do that, right? Because nothing stays up 100% of the time. You also don't have to write all of these things yourself, right? There are packages like Poly, which can help with that, right? You can define policies about retrying and circuit breaker and these things, so you don't have to reinvent the wheel about this. So let's say you have a function app with 4 major functionalities, but one part of these functionality sometimes fails, but it fails in such a way that it breaks down or causes a restart of your function app. So in this case, it's functionality B that causes a behavior. Of course, that needs to be fixed, but let's say that fix is not up to you. Maybe it's a third-party package that's responsible, or you're calling some certain other service that causes the issue. So what you can do then is make sure you isolate the issue, right? So isolate it in a dedicated function app. And in case that function app then fails, it doesn't affect the other components, right? So A, C, and D, just keep rolling. If you still need to do communication between, for instance, A and B, again, you can use a queue, right? So from function app A, you can put a message on the queue, and function app B is then triggered on the queue. But in case it's not working, function app B, well, the same happens before when we saw the example with the website. Messages will just pile up in the queue, but either this function app B will restart, or we can apply a fix there, and the message will be drained again. Again, a code example from durable functions, because they offer some nice functionality when it comes to resilience. Again, this is an example where we do function chaining, but now when we call activity function A, we use a method called call activity with retry async. Well, I think the name itself is pretty self-explanatory. And now we can provide as a second argument, retry options. So if we supply this argument, then when activity function A fails, durable functions will ensure that it will retry a maximum of 3 times. And it will first retry after 5 seconds, then it will retry after 10 seconds, and then after 20 seconds, because of this backoff coefficient of 2. So let's say by, again, moving some complexity, you can use turbo functions to make your function app much more resilient just by adding a few lines of code, which I think is really powerful. Okay, let's talk about the final strategy, and that's about scalability of your function app. So in computer and software science, there are two types of scaling. There's horizontal scaling, which means just increase the amount of machines, and there's vertical scaling, and that means increase the size of the machine, right, to have more CPU or memory. And by default, where the whole thing that serverless is based on, it's based on horizontal scaling, right? We have just a fixed set of CPU and memory. Usually it's very small machines initially, and we just add machines and add machines. And although this is a vertical stack, this is an example of horizontal scaling. This is just to mess you up. So, I'm sorry. So as an example, let's say your function app contains two functions, and if they are triggered at exactly the same time, they cause the same, let's say, CPU intensity profile. And when that happens, your function app will require to be scaled out. And although, that's one of the features of serverless, right? Dynamic scaling out and dynamic scaling in, it's great. But it's also not instant, right? The scale out, it always takes a couple of seconds. And again, when you're dealing with really high volume data processing, that's also maybe a bit time sensitive. Maybe that scale out happens a bit too late. So you only really want to scale out when it's really necessary. So ideally, you want to optimize that a bit. And so this is what I'm talking about. If your requests are increasing, functions will scale out. But especially in consumption plan, it will be a bit later, right? I mean, if you use premium plan, this is already a bit better, but maybe a bit exaggerated, but this is what's happening. It's always a bit later. So if you want to minimize this, so you still want to scale out, but only when it's necessary, you can do a couple of different things, right? So this is our function app with our two functions that will cause a scale out, and the other two, like C and D, they don't cause any difference. So one thing that we could do is we can take out one of the functions that cause the scale out, because now the function app that contains A can use its full resources, also B can use its full resources, so they're not competing on the same resources anymore. So basically you're just doing some manual horizontal scaling, right? Because you have a different function app, it means it will have its own instance when you're running this. The other option is actually to use vertical scaling, right? Because we can go from consumption plan to premium plan, and when we are in premium plan, we can actually choose a higher tier, which has more cores, or that has a more processing power, or has more RAM. And maybe when we are in a higher tier, we don't even require a scale out, right? Because we either have more cores, or the CPU is faster anyway. So this would be a perfect solution for that as well. If you want more control over scaling, which I definitely recommend, there are some settings that you can tweak here and there. So on the function app resource itself, there's the function app scale limit. So in consumption plan, things can scale out up to 200 instances, which is quite a lot. And maybe you have a very small SQL server at the end of your pipeline, and the SQL server cannot definitely handle these 200 instances of your function app. So you can actually set a value yourself to make sure that your function app doesn't scale out until this max number. Another thing which is important if you use premium plan or a full app service plan is the functions worker process count. Well, by default, on the consumption plan, you just have one core, and one core can run one worker. So by default, this is one. But if you use a higher tier, for instance, premium plan, well, then you can have, let's say, a 4-core machine, which means you can run more workers. But it does mean you have to specify this in this setting, right? So again, this can prevent some unnecessary scaling if you set this value to 4. Another setting, if you're really interested in how the scale controller performs, so the scale controller sits before your function app and is responsible for deciding when to scale out and when to scale in, and it's completely managed by Azure, and it's quite black box. But if you want some more information about the scale controller, you can set this value to true to make sure you have a bit more information inside how this scale controller is working. All right. So the take-home message for today for you is, please monitor your agility in any way you see fit, right? I mean, still, if you use story points, fine, but I think there are better metrics to look into. But please capture it and be knowledgeable about it. And if you see indeed that your agility is dropping, please find out what's causing it, right? And if it's your function app that's being more complex, then well, you now know what to do. And then ask yourself a couple of questions before you add any line of code to your function app, right? So, do I really need to write this, or could it be a package, or could it be a service? Is this what you want to add? Is it a good fit with the rest of the app, right? So does it fit in the same bounded context, or is it actually something else? And finally, what's the impact regarding resilience and scalability of the app, right? So is this new functionality, does it bring some more risk than the rest of the app is already having, or will it require a lot of CPU or RAM, and does the other functions also have a higher requirement for that? Again, all of these things require a bit of knowledge and measurement of what's going on. So again, logging and monitoring is really important here. Still have one shameless self-promotion for you. This is one of my final recent projects, ably.pizza.dev. So if you're interested in how to visualize your durable functions workflow in a front end, then you can use this example. There's a link to the GitHub repo in there as well to learn how you can use WebSocket-based technology to communicate status updates from a backend to a front end. If you have any questions now, that's totally fine. I'll also stick around later if you want to talk to me. Again, I will share the slide later on Twitter, so please, if you want to follow me, that'll be great. And please don't forget to vote as well. Thanks, everyone.